Hi folks, welcome to the chain rule recap. We're going to do this FAQ style, and here comes our first question. That's a great question to get us started off, Yellow Lion. The chain rule is a tool to differentiate composite functions. Those are functions with an inner and an outer part. Well, you use it when you differentiate functions with inner and outer layers. So if I think about two different functions like this, y equals sine of x and y equals sine of 3x. This one is the sine not just of x, but of some interior function right here. This needs the chain rule. This one doesn't really have layers. It's just the sine of basic old x. So it doesn't need the chain rule. Yeah, that's pretty important too. Well, the basic idea is that it's the derivative of the outer times the derivative of the inner. So if I have a function like this, it's already color-coded for me. The inner thing that is happening here is that I have a 3x. Okay. The outer function that is happening is that we have sine of something. And if we go and differentiate this, well, first I have to deal with that outer part. So the outer sine differentiates to cosine, we know that. And here's where most of the mistakes happen. Don't do anything to the inner part yet. Okay, so it still stays 3x. That's derivative of the outer. So I'll put outer prime here. And then I multiply the whole thing by the derivative of the inner. Derivative of 3x is just 3. I'll call that inner prime. And that means that the whole derivative is going to be 3 cos 3x. We can quickly go through a couple of other ones, but maybe we won't color code them. So in this one, we've got a binomial that's raised to the power of 7. So the inner thing is 2x minus 3. The outer is power of 7. So when we differentiate, we're just going to go. 7 comes down front. Power goes down by 1. Nothing happens to the inner yet. There's the derivative of the outer. Times derivative of the inner. So derivative of 2x minus 3 is just going to be 2. And we're pretty much done. Here's one with a square root. Let's rewrite it in exponential form. What's that? Yeah, you're right. The inner part is 5x minus 7. The outer part is power of a half. So let's deal with that power of a half. Nothing changes on the inside. power goes down by 1. Okay. Now times the derivative of the inner. Derivative of 5x minus 7 is 5, so this whole thing was outer prime. This is inner prime. And then you can write it however you want. Maybe you want to write it as 5 over 2 by 5x minus 7 to the negative half, or maybe you want to be fancy. Yeah, there can, and that can be tricky. But the big idea is that we just start with the outermost layer and we work our way inside. So here's one that has many layers. It's the square root of sine of 3x, which, no surprise, we're going to rewrite as sine of 3x all to the half. So when I look at that, I think the innermost thing that is happening is that I have a 3x. In the middle, I've got a sine. And the outermost thing that is happening is a power of half, or a square root. Okay, I'm going to rewrite that color-coded. So, let's make a little more room. Y equals. There we go. Now we can differentiate it. So I'm going to deal with the outer power of a half first. So power comes down front. Nothing inside that power changes yet. There is the derivative of the outer. Next thing I'm going to do is deal with the middle. There's a sine of 3x. So I'm just going to turn that into cosine. And the inner is not going to change yet. So cosine of 3x. And finally, so now that I've dealt with the middle, I'm going to deal with the inner. The derivative of 3x. You got it, it's 3. Okay. And now we've got all our layers dealt with, and we can put it all together. So this is 3 over 2, cosine of 3x, times sine of 3x, and that should have had an extra bracket there, all to the negative half. Or if you want to write it in fractional form, this is going to be 3 cos 3x all over 2 root of sine 3x. Okay, either one of these is fine. But that's how we deal with multiple layers. Work our way inside. Well, not exactly a question, but that's a fair point. When we combine the chain rule with quotients, products, factoring, reducing, things can start to look pretty rough pretty fast. I guess the thing I would recommend is to take a step back and realize that the most important thing is that you can do a simple one with an inner and an outer layer. After that, you can build your skills slowly from that. And if you find you need to go off to the side to find the derivative of the inner, that's fair too. Don't worry too much about getting the most elegant form of the answer to begin with. You can get sort of an unsimplified form and be happy with that, and then eventually maybe double back and see if you can factor it or put it in a nice form. Any correct answer is good, though. Yeah, that's a fair point. It does feel like it's everywhere. And that's because the questions that we did up to now were really contrived so that we could differentiate sine x, but maybe not sine even 2x. So if you feel like you're seeing it everywhere and you're worried that you're going to use it when you don't need it, you don't have to worry about that a whole lot. The bigger sin would be missing it when you're supposed to have it. So let's take a look at 2 quick examples here. Here I'd have an inner of 3x and an outer of sine. My derivative is therefore going to be deal with the outer of sine, so it'll be cosine of 3x times the derivative of the inner. So the answer here should be 3 cos 3x, and we did this question already today. You can see if you missed this 3, then your answer would be wrong. Here we should just jump and say the derivative is cos x, but what if instead you thought, oh man, I think that inner is an x, and there's an outer of sine, and you do all the work like that. So you go, okay, it's going to be cosine of, nothing changes in here, so cosine of x, and then I'll times it by the derivative of x, which is 1. What will you get in the end? You'll still get the right answer. Okay, so don't worry about overusing the chain rule. You'll still get the right value. That said, if you find yourself writing that the inner is x, that probably means that you didn't need the chain rule to begin with. We'll take a quick look at all the differentiation rules, and then you can take a look at the formative quiz.
So here are all of our derivatives. You can see them both with and without the chain rule. It seems like overkill to memorize separate rules with the chain rule. Just notice that there's that f prime at the end, and what that represents is the derivative of the inner. So don't forget to multiply by the derivative of the inner. Okay, now form Voltron and do that formative quiz.